Functions. The real valued function f of a real variable is a rule that assigns each real number x in a specified set of numbers called the domain of f a single real value number f of x. The quantity x is called the argument of f, and f of x is called the value of f at x. Function is usually specified in one of a couple of ways, either numerically using a table of values, graphically using a graph, or algebraically using some sort of formula. Note on domains, the domain of a function is not always specified explicitly. If no domain is specified for the function f, then we take the domain to be the largest set of numbers x, for which f of x makes sense. We call this the natural domain. Let's talk about these different ways that we can see a function. Here's a function defined by a table. Suppose f is a function specified by the following table. Here our x values are 1, 2, 3, 4. Our f of x values are 6, 4, 2, and 0. So the natural domain of f is the numbers 1, 2, 3, and 4. We can see here that f is not specifically defined, but there is an implied domain from the table. When x is equal to 1, we see that the function value f of x is 6, so we say that f of 1 equals 6. If we look at f of 1 plus 2, well, 1 plus 2 is 3. Order of operations tells us to add what's in the brackets first, so we get f of 1 plus 2 is f of 3, and f of 3, according to the table, is equal to 2. Note that f of 1 is equal to 6, and f of 2 is equal to 4, so f of 1 plus 2 is 10, whereas f of 3 is equal to 2. So we can't say that f of 1 plus 2 is equal to f of 1 plus f of 2. Here's a function defined by a graph. This graph is quantity as a function of price. Q is the number of smartphones in millions sold worldwide in a year when the price is P dollars. If we look at a specific value of P, say for example 160 or $160, we see that the quantity Q of P is 200 on the graph. So the x value is 160. We go up from 160 to the graph and over to the side and get the value Q of 160 equals 200. Here's an example of a function defined algebraically. Suppose f of x is equal to 3x minus 5. And f of 1 is the value of the function when you replace x with 1. So you get 3 times 1 minus 5 equals 3 minus 5 is minus 2. 0, for example, is 3 times 0 minus 5, or negative 5. F of m is 3m minus 5. Negative f of m is negative 3m minus 5, or minus 3m plus 5. F of negative m is different from negative f of m. We simply remove our x value and put in negative m, so you get negative 3m minus 5. The graph of a function consists of all possible points of the form x comma f of x for x in the domain of f. In practice, we can't plot all of these points because there's infinitely many of them. So we pick a few to plot and then play connect the dots. So for example, if f of x is equal to x squared, and we want to draw that graph, we start by choosing a few x values. It's best to pick x values that work out to be something fairly easy. So we're going to go integer values from negative 3 to positive 3. Negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. We plot those points. So for example, we plot negative 3 1, 2, 3, and 9, negative 2 and 4, negative 1 and 1, 0 and 0, 1 and 1, 2 and 4, 3 and 9, and then we'd play connect the dots.